Here we have a system as shown in this figure, two objects, one movable pulley on inclined plane as shown in this figure, and we have a friction force, coefficient of friction force also given. The first step, as usual, we need to draw free body diagram for each object. So let's start with this one. So downward we have gravitational force mg, upward we have a let me call it 2t, because here we have a tension 2 times smaller. That's why it's convenient for me to denote tension here 2t. We can also use t, but here we need to divide it by 2, t over 2. I don't want to work with t over 2. It's a little bit uncomfortable. And we have a reaction force upward, let me call it N1, and the friction force, directional friction force unknown here at the beginning. But we know that this system can move only downward or stay at rest. There is only two options. It cannot go upward because no one is pulling it upward. So there is only two options. It can move downward or it can stay at rest due to the friction force. So in any case, it's obvious that friction force will be directed upward. Let me call it F1. Because we have two objects, two different friction forces, let me call it F1. So these are all forces, I think, acting on this first object. And we know that it can move only in this direction. Let me call its acceleration A1. So I will assume it will move. As I said before, two options. So I will assume it will be moving. At the end, we can check it. Or we cannot check because numbers are not given. We don't know the mass in kilograms. We don't know coefficient of friction. So let's solve it as it is moving downward. So in this direction, we have driving force mg sine alpha. And the friction force is trying to stop. Also we have a 2t equal to mass times A1. This is a Newton's second law, second equation for the first object. And we are assuming that this object is moving. It means friction force already reached its maximum value. It means F1 should equal to K times coefficient of friction times reaction force. In this case, reaction force, it's very simple, it's obvious, equal to mg times cosine alpha. So let me substitute friction force into the first equation, and finally we'll have this kind of equation: mg sine alpha minus k mg cosine alpha minus 2t equal to ma1. Now let's come to the second object. Let's draw a free body diagram again for the second object. Downward gravitational force, reaction force perpendicular to the surface. Rope is pulling it downward, so same tension but directed downward along the inclined plane, and we have its own friction force. This object also can move only downward or stay at rest. So we are assuming that it will move. So let's call its acceleration A2, direction downward. Again, let's write Newton's second law for this object. Downward we have a tension. Also downward we have its gravitational forces component mg sine alpha, tension, and the friction force is trying to stop it. Mass times its own acceleration. Since we have a complex system, I'm assuming that they will have different accelerations. Then we need to find the relationship between these two accelerations. So again, this object is moving, so friction force reached its maximum value. So similar logic we will use. K, coefficient of friction times reaction force, which is mg cosine alpha. So let me substitute it into this equation, and finally we'll have T plus mg sine alpha minus K mg cosine alpha equal to MA2. Equation number 1, equation number 2. As you see, we have three unknowns, A1, A2, and tension. But we have two equations. We need one more equation. It's obvious that from previous lessons we know that it should be a relationship between accelerations. In order to find the relationship between A1, A2, we need to draw two figures at the beginning of the motion and after some time. So let's start. This is at the beginning. This point is this point. This is the end of the rope where this object is attached. I will not draw this object again. This part of the rope is fixed. It's not moving. So this length, let me call it L1, upper part. Here we have a rope, let's call it the length of this rope L0, sorry. And the length of this part, let me call it L2. So total length of the rope, L1 plus L0 plus L2. And we know that this rope, this string is inextensible. So total length should be same during the motion. So after some time, this rope will take this position. Roughly, rope will be here, for example. This object, let's assume it shifted for x1 distance. As you see from this figure, this pulley and this object is attached with help of this rope, so they will move always together. So displacement of this pulley will be equal to displacement of this object. So it shifted for x1, yes? So this part equal to x1, this part also equal to x1, yes? This object, let's say it moved downward for x2. Now let's write new length of the rope, which is equal to the initial one. So length of the rope here equal to what? L1 plus x1 plus here again we have L0. Now let's come to this part. Initially here this part was equal to L2 plus x1 but minus x2. L2 plus x1 minus x2. So now let's continue. L1, L0, L2. It cancels each other. So here at the left side you have a 0. At the right side you have 2x1 minus x2. So 2x1 equal to x2. We know that x1 is proportional to a1, x2 is proportional to the a2. So we can say 2a1 equal to a2. And this is our last equation. So that's all. Further is totally mass. At this point, till this point, we already finished physics part. We derived 3 equations. That's all. And we are 100% sure that we have a correct, right equations. Now, further is totally mass. And somehow we need to solve it. Okay, what I will do, I will take a1 from the first equation and substitute into the here, and this a2 from the second equation will bring it into the equation number 3. And in this equation we will have only one unknown, tension. First of all we will find tension. So okay, let's go. A1 from the equation number 1, let me divide both sides by m. So A1 equal to G sine alpha minus KG cosine alpha minus 2T over M. A2 from second equation, let me again divide both sides by M. So T over M plus G sine alpha minus KG cosine alpha. So now we will take it into the equation number 3. 2A1, we need to multiply this part by 2. So basically 2G sine alpha minus 2KG cosine alpha minus 4TM equal to A2. G sine alpha plus KG cosine alpha. Let me bring 4Tm to the left side, so we will have 5T over M. Here 2G sine alpha, G sine alpha, here we will have only G sine alpha. And 2kg cosine, kg cosine, here we will have only negative kg cosine alpha. It means I can take G outside, or let's leave it like that. G sine alpha minus kg cosine alpha equal to 5Tm. From here, T over M equal to G sine alpha over 5 minus kg cosine alpha over 5. Why T over M? Because here for A1 we need only T over M. And we already know what is a T over M. So we need to substitute into this equation and find A1. So A1 equal to G sine alpha minus kg cosine alpha minus 2Tm. 2T over M. This is T over M, so we need to multiply by 2. 2G sine alpha over 5 minus it will be plus 2kg cosine alpha over 5. So finally A1 equal to 3G over 3G sine alpha over 5. Here negative 3, yes, minus 3kg cosine alpha over 5, or we can say 3g over 5 sine alpha minus k cosine alpha. This is A1. A2 equal to A1 times 2. So we will assume that A2 is already given, or we found it already. So A1 is, we found it, so A2 is not problem.